between bagging versus boosting? What is the difference between bagging versus boosting? Okay. What is the difference between bagging versus boosting? So let's see the differences. What are the differences we are having in the bagging, boosting? What is the difference between the bagging versus boosting? So in the bagging, whatever we are having in the bagging, we are going to create the multiple decision trees. We are going to create the multiple decision trees. Here also, we are going to create the multiple decision trees. In the both of them, creating the multiple decision trees is common. Okay, in both of them, creating the multiple decision trees are common. In the bagging also, you are going to create multiple decision trees. In the boosting also, you are going to create the multiple decision trees. Now here, whatever the decision tree is there, each decision tree is fully grown, completely grown. But here, each decision tree is not fully grown. It is pruned. Each decision tree is pruned. Every decision tree is pruned. Okay. In this bagging technique, all the decision trees are fully grown. In this decision tree, the decision trees are pruned. Right? Next, coming to the next one. Here, in the bagging technique, whatever we are having, the decision trees, each decision trees, whatever the decision trees are there, decision trees are independent to each other. Independent to each other. Whereas here, the decision trees are dependent to each other. Dependent to each other. Okay, they're having the dependency between them. And here, the decision trees, whatever the decision trees are there, are created by subset of data, random subset of data. They are created based on the random subset of data. Here, the decision trees are created based on the error of first decision tree. The second decision tree are created based on the error of the first decision tree. Second decision tree is created based on the first decision tree, and so on. Means, to be more precise, the n plus 1 decision tree is created based on the nth decision tree, based on the errors of the nth decision tree. So they are created in terms of by connections between them. Okay, and this is called as parallel learning. This is called as parallel learning. Why it is called as parallel learning means because there is no connections between the decision trees. All decision trees are independent to each other, so it is called as parallel learning. Since all the decision trees are independent to each other, it is called as parallel learning, whereas this is called as sequential learning. This is called as sequential learning. One is called as parallel learning and one is called as sequential learning. Right? Parallel learning and sequential learning. Now, let us understand clearly now what is meant by boosting. Already we have seen the bagging technique, that is random forest, where all the trees are independent to each other. The first decision tree, second decision tree, third decision tree, they are not having any dependency. The second decision tree is not decided based on the first decision tree. Oh, first decision tree has selected this is the subset and it has given the answer like this. So second decision tree should be selected like this. There is no rule. Each decision tree is independent to each other. There is no connection between them. Everything are independent to each other. But whereas in the boosting, everything are connected to each other. All right. Now, so here, the boosting technique, whatever the boosting is there, let us understand clearly about the boosting. In the boosting, what happens means it is going to create the multiple decision trees. Okay. We are going to create the multiple decision trees. Now here, what are the multiple decision trees are there? It is going to create the multiple decision trees, and these decision trees are connected to each other. Now, how they have got this idea? From where they have invented this one? Okay, random forest, we have seen how they have invented and how they have created. Now, this one, they have observed after, for example, we are taking one exam. Okay, one exam we are considering. Okay, let me write like this. Let me consider like this. Just give me a minute, guys. Okay, so from where they have created this one means invention. For example, there is an exam. In the exam, I'm going to keep on the core Python, Python for data science, descriptive statistics, inferential statistics, EDA, data cleaning, data wrangling, and regression and classification. This is the syllabus. Exam syllabus is this one. Assume this is the case. Now, in that you have taken the exam. In your exam, you have got each you have got with respect to for each category certain marks are allotted, and out of all of them, you have got a very good score in core Python, Python data science, descriptive statistics. But in inferential statistics, you have got a less score. Assume. And in the EDA, you have got a less score. In data cleaning, data wrangling, and regression, you have got a less score. And classification, you have got a good score. Like this, you have done. 3 areas, you are weak. On the 3 areas, you are weak. And remaining areas, you are good. After taking the exam, you analyze that one. And each of them, for example, 3, 6, 9. Okay, total 9 categories are there. Each of them, I'm going to take 100, 100, 100 marks. For each of them, 100, 100 marks. Out of 100 marks of each category, you have got a very good score in the 6 of them, but in 3 of them, you have got a very less score. You have observed that one, okay, I'm very weak at the inferential statistics and EDA and regression. You have observed yourself. Now, after observing what you are going to do, now, once again, you are going to prepare this one, which you are going to prepare. Again, you are going to prepare core Python and Python for data science. Again, you are going to prepare this one. Huh? No, right? Which one you are going to prepare? You are going to prepare only the inference statistics, EDA, and regression. So wherever the weak points are there, that one you are going to focus and you are going to prepare. And next time, after taking the exam, one more time, if you take the exam one more time on the same syllabus, this time you are going to get a very good score. Why? What is the reason behind that? You identified what is the drawbacks. That is all the weakness. Where is the problem is there? And you have rectified that problem. The same thing is called as boosting. In the boosting, first it is going to create the first decision tree. One decision tree it will create. After creating the first decision tree, it will get some of them will be correctly classified, some of them will be wrongly classified. Some of them will be correctly classified, some of them will be wrongly classified. Whichever wrongly classified, which records are wrongly classified, it is observing what is the problem and it is rectifying that one. Now, wherever the records are wrongly classified, after that, wherever the records are wrongly classified, finally it is rectifying everything and it is trying to get the best. Is that clear, guys? Now let us observe this one. For example, I'm saying the same example. I'm conducting them for each of them 100 score. For each of them 100. Okay, everything is of 100. And you are taking the multiple attempts. There is no restriction. You can take n number of attempts. This exam, but each attempt you attempt the exam, each time you'll get a different questions, not the same questions. Okay, so assume that I have created one app or one site something where by using the login, once you click on that, you'll get a sample questions. Now that sample questions, once you take the exam, for each category 100 marks I'm having, and you are going to take the exam. And after taking the exam from each category, after that, now once you submit, once the exam is completed, you can see the score in the core Python. You can see the score in the Python for data science. You can see the score in the descriptive statistics, inference statistics, EDA, data cleaning, data wrangling, regression, and classification. You can see your scores, whatever the scores you are having. Now, this scores, whatever the scores you are having, now after that, you are going to observe, there is your problem. So you have observed the problem is here, here, and here. Remaining all of them are very good. You are okay with this one. Okay, these all of them are, you are okay. Now, coming to this. Okay, this. Now, what you are going to do, this is your first attempt. Your first attempt. After your first attempt, now you are going to practice on the inference statistics, EDA, and regression. In the second attempt, you are make sure that you'll get a very good score in this area. In your second attempt, once you take your second attempt, you are getting a very good score in which, where you are getting a very good score in the inference statistics. In the inference statistics, you are going to get a good score. And in the EDA, you are going to get a good score. And in the regression, you will get a good score. Now, but this time you have failed in the Python for data science because the questions are different now. Now, this time you have failed in the Python for data science. That is Pandas questions you have failed because while preparing the second attempt, you have focused you have dedicated your maximum time on the inference statistics, EDA, and the regression. You dedicated your time on that. You have not dedicated the time and you have not revised the Python for data science. You have dedicated your entire time on the inference statistics. You have dedicated your entire time on the inference statistics. On inference statistics, on EDA, and regression. In the second attempt, you have successfully completed this one, but you have failed here. And in the descriptive statistics, you have failed. And this one you have successfully created. Everything you have successfully created. Now this time, these two you have failed. Now next time in the third attempt, now which one you are going to focus? Now you are going to focus on the Python data science and descriptive statistics you are going to focus. And this time you make sure that whenever you are taking the attempt, the previous misclassified records, whatever the previous misclassified records are there, that should be correctly classified. New one might be error. Anything others might be error, but whichever you are focusing, that should be cleared first initially. So you are going to take this one. Again, you are going to take this like this, like this. Now this time you have failed in the classification. Now you are taking the fourth attempt, attempt number 4. Now this time what you are going to focus on the classification, you are going to focus and make sure that in the classification you will get the best score. Like this, you are going to take the multiple attempts and multiple things you are going to focus until you get the 100% accuracy. You'll do the attempts. Every time you'll check yourself where is the drawback, and again you'll do, and you'll try to rectify your drawbacks. Multiple times you'll get a new mistakes. Human miss, commonly they are going to do the mistakes. Today you have done this mistake. Tomorrow you might do a different mistake. Day after tomorrow you might do a different mistake. But once you rectify all your mistakes day by day, one after one day it is going to be a perfect one. Some day will be there. It can't be immediately. Next day itself you can't be a perfect person. Some day will be there. When you are rectifying all your mistakes, what are the things you have done? One day will be there where you are going to have with respect to 100% perfectness will be there. The same to same here. Okay, the same to same. So in the this particular boosting technique, what happens means it is going to focus on the misclassified records. It will focus on the misclassified records in the first decision tree, and according to that, it will create a second decision tree. The second decision tree, how it is created means first it will observe what are the misclassified records in the first decision tree. Which records are misclassified in the first decision tree? Based on that, it is going to create the second decision tree. How the second decision tree will be created means such a way that all your first decision tree misclassification records are there. Everything will be correctly classified. Got the point? So for example, your first decision tree number 1. In the decision tree number 1, third record, eighth record are misclassified. Third record and eighth record, these two are misclassified. Now, second decision tree was created in such a way that these two correctly classified. It will focus in such a way, these two are correctly classified. Sir, how it is going to do that one, sir? It will create a condition in such a way. It will write the condition where these two will satisfy. It is completely condition only, na? It is going to write the condition which satisfies these two records. Like that, it is going to write the condition. And like that, it is going to make sure that these records are correctly classified. Now, while focusing on these records, other records might be misclassified. Now, again, you are going to, like this, you are going to take each and everything. And finally, if you combine everything, finally, you have to combine everything. When you combine everything, what happens finally? It is going to give the maximum accuracy. So the same thing in the here also. So the best example for the boosting is Avengers. I think everyone knows Avengers movie, right? In the Avengers, we are having different superheroes are available. Iron Man is there, Captain America is there, Thor is there, Ant-Man is there, something. Okay, multiple superheroes are there. Individually, each superhero is a separately hero. Now, if you observe the Endgame, have you seen the Endgame movie? Avengers Endgame. In the Endgame movie, that is whatever the final villain we are having in the Endgame, to defeat that particular person, once Iron Man is not sufficient. So individually, Captain America is not sufficient. Individually, Thor is not sufficient. Now, what they have done? They have combined. At the end, everyone has combined. They made with respect to a teamwork. Means in terms of they have combined, and finally they have defeated the main other opponent person, right? The same thing. So just each decision tree, whatever each decision tree is there, separately superhero only. Now you are going to combine all the decision trees. In the random forest, you have not combined them. Individually, you have worked separately. You have worked on the each decision tree separately, and you have taken the overall with respect to mode you have applied. Answer you have got separately from the first decision tree, from the second decision tree, separately you have extracted the answer. After extracting the answer from each decision tree, in each decision tree, one answer you are having. Finally, you applied the mode. Mode means which is most repeated one in the random forest. But here, we are going to combine them directly itself. While creating the decision tree only, we are going to combine them. And in the this one, all the weak learners are combined to make a strong learner. In order to make one strong learner, we are combining the weak learners. Directly, single decision tree is a weak. But if you combine these three people, okay, individually they are waste. But if you combine three of them, they'll make us a strong. So like this, we are going to work on the boosting technique. Boosting means combination of multiple weak learners. Okay. Now, here I'm having with respect to a combination of multiple weak learners. Now it is called as sequential learning. Sequential learning means whatever the data you are providing here, the decision tree, first decision tree, and the second decision tree is decided based on the first decision tree outcome. Second decision tree was created based on the first decision tree outcome. Without the first decision tree outcome, the second decision tree we can't form. They are not independent to each other. They are dependent to each other. right? So this is called as sequential learning. In the sequential learning, the boosting techniques, we are having different types of boosting techniques are there, out of which the first one is called as ADA boost. Now, what is meant by ADA boost? ADA boost means in terms of you are having a sequential data, one by one the sequential data with respect to, and this, just observe this one. I'm going to explain with a simple example so that you'll understand the entire ADA boost in a simple way. Now here, just observe this. This is the data set. Okay, this is the data set where I'm having the pluses and minus. And I want to divide the data. I want to classify. In the KNN, how we are going to classify this one? In the KNN or in others means, for example, SVM you are using, you have to draw only a single line. You can't draw multiple lines. You can draw only a single line. But whereas in the decision tree, you can draw the multiple lines. So you can draw a line like this, like this, like this. You can draw a multiple lines like this. The same thing here, you can observe this one. In the ADA boost, first decision tree, first decision tree, I'm going to draw this one. This is the first decision tree number 1. Now, decision tree number 1, whatever the decision tree number 1 is there, this decision tree will take one condition, some condition. This is the condition. It is going to take the condition, and based on the condition, it is going to separate the data into 2 parts. This is the one part and this is the second part. Now, after this, in the normal decision trees, generally, in a normal decision trees, what we are going to do? We are going to write one more condition. And again, we are going to divide the data, right? But here, in this ADA boost, what we are going to have is each decision tree is called as, in ADA boost, each decision tree is called as stump. Each decision tree in ADA boost is called as stump. Each decision tree in ADA boost. Each decision tree in ADA boost is called as stump. Now, what is meant by stump? Stump means a decision tree with maximum depth is equal to 1. Stump means decision tree with max depth is equal to 1. Stump means a decision tree with max depth is equal to 1. Means it is going to have one root node plus 2 leaf nodes. A stump will have one root node with 2 leaf nodes. That's it. That is called as stump. If you observe, I have told you earlier, what is the differences between the bagging versus boosting in the today's in the just have 10 minutes or 15 minutes back. In that, I have told you each decision tree is pruned. In the boosting, each decision tree is pruned. So here the pruning was done with maximum depth is equal to 1. Maximum depth is equal to 1 means you can write only one condition. You can't write the multiple conditions. You can write only one condition, and you can draw one line and you can divide the data. You can't draw multiple conditions. Each decision tree is pruned. Now, here, if you observe, this is the data. In this data, I'm going to take one decision tree, that is condition. This is the condition. Let us assume this is x2 and this is x1. And based on x1, I'm going to write one condition. If it is less than to this, it is called as blue category. If it is greater than to this, it is called as orange category. Something I have written like this, assume. Now, here I'm having with respect to x1 and x2, and based on the x1, I have divided the data. How you selected x1 means, again, Gini impurity only. It will calculate the Gini impurity of x1, Gini impurity of x2, and which one is having the least Gini impurity, it is going to select that one only, right? Now, it is going to draw one line. Now, these both are correctly classified. Now, coming to this, these 5 records are correctly classified. Which are wrongly classified? These 3 of them are wrongly classified. Can you observe? Basically, these 3 should be orange color, but you have got as a blue color. Left side to this is a blue color. Right side to this is a orange color. Okay, these 3 of them are wrongly classified. Now you have to create the second decision tree in such a way that these 3 should be correctly classified. So now the second decision tree was written by writing like this. That is decision tree, second decision tree. This time I'm writing x1 is less than this value. For example, this value is 100. This value is 20. Assume any value less than 20 is considered as blue color. Any value greater than 20, x1 is greater than 20 is considered as orange color. Now here, these three data points are wrongly classified. Now what happened? Now second time I'm going to take this time x is less than 100, blue color, greater than 100, orange. Okay, orange means nothing but minus. Orange means minus, blue means plus. Now here, if you observe in this, these three are correctly classified. Whatever the three was wrongly classified in the decision tree 1, those are correctly classified in the decision tree 2. Done? Correctly classified. But this time, these three are misclassified. Now you have to create a new decision tree in such a way that these three should be correctly classified. So now you are going to create one more decision tree like this. And these three are correctly classified. Now if you combine these three, finally, if you combine the decision tree number 1 and decision tree number 2 and decision tree number 3, you will get with respect to a 100% accuracy. You can observe this by combining these three of them. That is the first line. This is the first line, first decision tree. Second line, this is the second one, third one. By combining these three, finally you got as a 100% accuracy. So now everything was correctly classified. Can you see? Is that clear? Individually, this is a weak. Individually, this is weak. Individually, this is weak. Three of them are individually weak learners. This is called as weak learner. This is called as weak learner. This is called as weak learner. Now the question is, what is meant by weak learner? Weak learner means a model which can't classify perfectly. A model which can't classify perfectly, it is called as a weak learner. What is a strong learner? A model which can classify perfectly is called as a strong learner. So here, this weak learner cannot classify entire things. Multiple mistakes are there. 3 records are misclassified. In this, 3 records are misclassified. In this, these 3 are misclassified. Individually, each of them is a weak learner. But if you combine these 3 of them and if you make a strong learner, now this was all the mistakes has been rectified. This is called as boosting technique. Is that clear? Now, sir, okay, visually it is clear, sir. Now, how the decision tree knows that one? Okay, the second decision tree, how it knows that these 3 are misclassified. Here, visual representation is clear because you have taken only 2 columns, x1 and x2. So for 2 columns, visual representation, okay. But if you are having 10 columns or 20 columns, visual representation we can't make now. Then in that case, how the decision tree will work generally? How the second decision tree knows these are misclassified? Means it is going to apply some max behind that. It is going to do some max behind that. What is the max behind that? Means the max behind that is nothing but, so here, whatever the 3 decision trees are there, it is going to create one by one. And so here, the max, let us see the max. What is the max? And how it knows that which decision tree is wrongly classified. For example, let us take few records. Actual data. Let me write here actual data. And predicted data. Now, actual data, I am having yes, no, yes, no. Total 7 records are there. I have written randomly 7 records. Now here, while prediction, it is predicting yes, no, yes, no. It has predicted. The model has predicted. Which model? Weak learner 1. First only. Directly the first weak learner 1. The first decision tree has predicted the answers like this. Now after this, how many records are misclassified? 1 record was misclassified. Now this misclassified record the second decision tree has to correctly classify and it has to give the answer as X. In the second decision tree, the answer should be yes. Now, how the second decision tree knows this is misclassified? This record only misclassified. How the second decision tree knows means how it is going to work means first it is going to take the initial weight. Initial weight. What is initial weight means 1 by n, where n is the total number of records. For the first record, the initial weight is equal to 1 by 7. Second record 1 by 7. Third record 1 by 7. Fourth record 1 by 7. Fifth record 1 by 7. 1 by 7 and 1 by 7. Now, if you do the total, what is the total weight? 7 by 7, which is nothing but 100% is the total weight. Now, for each record, equal weight you are going to assign. Out of which here, this one was misclassified. What is the weight of the misclassified record now? Weight of the total error. Total error is equal to 1 by 7. For example, sir, instead of one record, this one also misclassified, sir. Two records are misclassified. Then 2 by 7. 1 by 7 plus 1 by 7. Whatever the weights are there, you have to add the weights of all the misclassified records. Weights of all the misclassified records. Is that clear? That is called as total error. If one record means 1, 2 means 2, 3 means 3, 4 means 4, 5 means 5, 6 means 6, 7 means 7. Whatever the number of records are misclassified, every misclassified record weight will be there, right? That weight you have to add. From that, you have to calculate the alpha. Alpha means performance of the stump. How your stump is performing. How it is calculated means 1 by 2 into log E to 1 minus TE by TE. That is 1 minus 1 by 7 divided by 1 by 7. That is 1 by 2 into log E. That is 1 minus 1 by 7 divided by 1 by 7. 1 minus 1 by 7 means 6 by 7. 6 by 7 divided by 1 by 7. 7 cancels, which is nothing but half of log 2 base is 6. And it is going to calculate this value, whatever the value is there. Now, once this value is calculated, the alpha is calculated. Now, it is going to assign the new weights. It is going to assign the new weights. Once this is done, it is going to assign the new weights. How it is going to assign the new weight? How it is going to assign the new weight means old weight. Whatever the old weight is there, the old weight into e to the power of stump, that is alpha, performance of the stump. Okay, and this is for the new weight of the correctly classified record. For wrongly classified record, new weight is equal to old weight, whatever the old weight is there, the old weight into e to the power of plus alpha. One is with minus alpha, one is with plus alpha. Now what happens means whichever is wrongly classified, that particular record, whichever is wrongly classified, not only one record, whichever the records are wrongly classified, all the wrongly classified records, the weight will be increased. The weights will be increased. Of what? Of wrongly classified records. Of wrongly classified records, the weight will be increased. At the same time, for weights will be decreased. Weights will be decreased for the correctly classified records. For correctly classified records, weights will be increased for the wrongly classified record, and for correctly classified records, the weight will be decreased. So from this, the second decision tree will understand which record weight was increased. That the second decision tree will understand, okay, these records are wrongly classified. In that way, the code was given. To be more simple, sir, if anyone asks you the interview, no need to explain this much of process. Simply say that how the Adapt Boost, the second decision tree knows which records are misclassified, sir, the weights will be increased. Whatever the weights of the data is there, the weight of the records will be increased for wrongly classified records. The weights of the records will be decreased for the correctly classified records. Initial weight is this one. This is the initial weight. The weight will be reduced. For all the correctly classified records, the weight will be reduced. For wrongly classified records, the weight will be increased. Simple. In one shot, you can conclude like this. Is that clear, guys? Done? Online students? Since I'm having with respect to this pen problem, today my pen, whatever the pen which I'm going to use for writing the notes, it is not working. So I'm writing with my hand. Using my finger, I'm writing this one. So somewhat it might be not clear, the words. Is that okay, right? Online students? Yeah. Basically, pen is not working. I'm using my hand. Since it is a touch screen, I'm using my hand and I'm writing. Right, guys? So this is the formulas. What are the step-by-step procedure is there? I have explained just now the step-by-step procedure, right? The entire step-by-step procedure is this one. So first it is going to consider the initial weight. And from that initial weight, it is going to calculate the total weight of the errors. And after calculating the weight of the errors, it is going to calculate the performance of the stump. From that performance of the stump, it is going to calculate the new weights. Okay. Once the new weights are assigned, whichever the weight has increased, that is wrongly classified. Whichever the weight is decreased, that is correctly classified. Simple. That is very simple. Is that clear, guys? Done? Can you explain once the fifth step? That's why explanation and the equation. Okay. Yes. Fifth step is nothing but you are going to take the old weight. Okay. So I'm writing once again here. First, you are going to choose the initial weights. After that initial weights, you are going to calculate the total weight of misclassified records. Misclassified records. Or otherwise, I'll detect. Can you write? And can you write, guys? Write in the notes. I will detect. First, step by step steps involved in the Adapt Boost. Steps involved in the Adapt Boost. Steps involved in the Adapt Boost. Step number 1. Step number 1. It is going to initialize equal weight. It is going to initialize equal weight for all the records. It is going to initialize equal weights for all the records. And the initial weight is equal to 1 by n. And the initial weight is equal to 1 by n. That is the point number 1. Okay. Where initialization with equal amount of weights. Second, next step number 2. It calculates the total weight of the misclassified records. It calculates the total weights of the misclassified records. It calculates the total weight of the misclassified records. And step number 3. using the total weight of the misclassified records, it is going to calculate, it will calculate the performance of the stump. It will calculate the performance of the stump, which is nothing but alpha, in bracket alpha. It will calculate the performance of the stump called as alpha. Step number 4. Using the alpha, the weights of the each record will be modified. Using the alpha, the weights of each record will be modified. Next step. While modifying the each record weight, all the correctly classified records weights will be reduced. All the correctly classified record weights will be reduced or decreased. And wrongly classified records weights will be increased. Right? Last step. Now, next decision tree will identify which record's weight is more. And it will try to rectify that misclassified records to correctly classified records. Is that clear, guys? The next decision tree, what are the next decision tree is there? The next decision tree will identify which record weights are high. Those records, those records are there, that misclassified records will be correctly classified it will be correctly classified. Clear, guys? So in that way, the ADA boost is going to work. Done? I'm not writing anything, just I'm detecting. Now coming to the next one called as gradient boost. The next one is gradient boost. Now, instead of going with the gradient boost theoretical part, because again, the pen is not there, right? It will be very difficult to explain and a step-by-step procedure. So let us see the gradient boost in the tomorrow's class, and we'll complete the coding part of the ADA boost today. Okay, let us see the coding part of the ADA boost. Now, I'm taking the coding part of the ADA boost, where this particular project is related to mushrooms. As everyone knows about the mushrooms, we are having different types of mushrooms are available. Okay, mushroom is this one. right? Everyone knows mushrooms. In the mushrooms, some of them are poisonous, some of them are eatable. Okay, some mushrooms are good and we can eat that. Some mushrooms are not good. Okay, so which mushroom is good one? Which mushroom is a bad one? So that we have to see. So here here we have to predict this one. Now, whether the mushroom is a good one or a bad one based on the data. Now, why I have selected this project? Is this project we are going to do in the real life? Means this project is useful in the real life? Means yes, it is useful in the food processing companies, but very less number of opportunities are there in the food processing companies as a data scientist. Generally, in the food processing companies, data scientist work will be very less and they'll not hire generally. Now, coming to this particular mushroom, then why you have selected, sir? This is not having any importance now. Then why you have selected this project? You can take any other project now. Why you have selected this one only? Because here this project consists of total 23 columns. 23 columns are there, out of which one column is the output variable. That is whether the mushroom is a good one or a bad one. Okay, that is a discrete variable. Remaining 22 columns are there. Okay, what is the special? These 22 columns are completely categorical. Not even one numerical variable also is there in this entire data set. Now, the reason behind selecting this particular project and this particular data set, reason behind that is, earlier I used to work on a different data set. Okay, 2 years back, I used to work on a different data set. 2 years back, one of the student, he has completed the course and he has got a job. And while he doing the project, he has got one doubt. At the time, he has sent me a message on my LinkedIn profile. Okay, generally I will share my LinkedIn profile to every student. So he has sent me a message. What is that message? Means, sir, I have received a data set. In this data set, only categorical labels are there, sir. This is not the data set. That is a different one. Okay, only categorical labels are there, sir. No, with respect to one of the continuous variable is also not there. And now I have to work on this particular data set, it seems. Now, what we have to do, sir, means here here, if you take this one, 22 columns are there, 22 input columns, 23 are there, original data 23. Out of 23, 22 are the input columns, 22 are input columns, and one of them is output column. Anyways, output column is common for anyone, anything. STS penguin data set also output column is common. Whether it is a cancer data set also output column is common. Everything output column is common. Now 22 input columns are there. 22 of them are discrete categorical only. There is no one continuous variable also. Now he has got a question. That particular student has got a question and he asked me that, sir, in my entire data set only categorical labels are there. There is no with respect to continuous, and how I have to proceed. He asked me that question. Suddenly I was shocked. What is this question? Why he is asking like this? Generally for categorical data, what we'll do? Encoding we'll do and we'll continue. Nothing special now. Normally encoding we'll do and we'll apply the machine learning algorithm. Suddenly he has got a doubt. Why he has got a doubt? I have messaged him and I have sent a reply that just to do the encoding and complete the process. Now he asked me, sir, if entire data set consists of complete categorical also, should we do the same? He asked me that question. Suddenly I have got a doubt. Oh, this type of suddenly for some new students are there, and for the new students, if they're getting this type of data set, means for them also it is going to be a problem in the future now. Then why can't take this type of data set, one of the example in my project, and I want to explain. That is the reason I have selected this one. The reason behind that is this, right? Basically, it is not having any application. This project is a normal one, a basic normal project. A mushroom data set means generally in real life, it is not having any importance, basically, right? Now, here in this data, what are I'm having this data set? If I observe this one, total I'm having 23 columns. Out of 23 columns with 8,124 records. Now, the output variable, whatever the output variable is there, I'm having the output variable called as E and P. The name only E P they have written. Now what is meant by E and what is meant by P? I have done the data understanding. This is the data understanding. In the data understanding, the output is either edible or poisonous. Okay, E means which you can eat, and which is P means poisonous, which is poisonous one. And here, if I observe this one, other columns, if I take the other columns and if I apply the describe function, now I'm having in the each of them only a single letters are there. Can you observe here? Cap shape. What are the cap shape is there? X is there, B is there, X, H, F, K, something you are having. A single letters. What is this single letters? Now, what is meant by cap shape? So, if you go with the mushroom data, for this mushroom, you are having a cap, the shape of the mushroom. What are the shape is there? The shape is called as cap. Now, this shape will be different shapes are available. What are the different types of shapes of mushroom shapes are there? Miss, one is bell shape, conical shape, convex shape, flat, knobbed, sunskin. So we are having different types of shapes of the data are available. So what is B means bell? What is C means conical? What is X means convex? The shape is convex. So here we have to understand this data set very clearly, and what are the different types of variables are there. And here these are the different types of list of variables and the names. Now I'm going to do the EDA, and in the EDA, if I apply describe function, I'm going to get only the unique top and frequency, because I'm not going to get in terms of mean value or 25 percentile, 50 percentile. That is for continuous variable. For numerical data, it is going to print like that. For discrete variable, how it is going to print? I mean categorical data, it is going to print the unique values. Means in this particular column, how many unique values are there? 6 unique values are there. Top, what is meant by top means mode. For discrete variable, it is applying the mode concept, and it is going to give the mode. Most of the variables are X. X means which is nothing but convex, which is having a convex shape. And which is most repeated means 3656 records are there with of X. The mode is X now. How it is setting the X means because the frequency. What is the frequency of the top category? That is 3656. Means out of 8124, 3656 records are with respect to X shape. And now here, if you observe sum of the columns, it is printing the sum of the columns, and last some columns in between dot, it is printing. Now for remaining variables, I have to see like this. Means how I can know? By applying the transpose. Now, if I apply the transpose, now I can see each and every column. For each and every column, what are the unique? The same thing. What are you having here? Just you are doing the transpose, so that these dots also you can see. Now you will not get the dots. Right? Next, is null dot sum. Means I'm checking whether missing values are there. No missing values. Next, what I'm going to do? I'm going to do the encoding. For doing the encoding, first, I'm going to drop the output variable. Now, whatever the remaining input data is there, the input data is of 22 columns. These 22 columns, I'm just doing the one hot encoding, because everything are nominal data. Just their names, colors, what is the shape of the mushroom, and what is the color of the mushroom, and what is with respect to the length of the mushroom. All these things, everything, whatever I'm having, everything is a nominal. Nothing is ordinal is there. Everything are nominal. Since everything are nominal, just I'm going to apply the pd dot get dummies. Now, if I check the get dummies means now 22 columns. What are the 22 columns are there? Input data of 22 columns. These 22 columns has been converted to 95 columns. Can you see here 95? 8124 into 95. So 95 columns it has created. From where? From 22 columns. Input data is 22 columns. This input data was converted to 95 input columns. Output column anyways common. There is no difference in the output column. So now 22 input columns has been converted to 96 input columns by doing the one hot encoding. Now I'm going to apply this train test split. After applying the train test split, now these are the values. Now here modeling. First, what is the modeling I have to do? Modeling with the default parameters and evaluation. After that, hyperparameter tuning. Once the hyperparameter tuning is completed, again rebuild the model. From the decision tree onwards, what you will get? Future importance also you are going to get. Using the future importances also, you are going to identify which are the important futures, which are the important hyperparameters. Using the important futures and important hyperparameters, you are going to finally build the model. Same to same I'm going to do. First, from sklearn.assemble, I'm going to import the AdaBoost classifier. Yesterday, I have imported from sklearn.assemble random forest classifier. Today, I'm importing the AdaBoost classifier. And I'm going to take the model is equal to AdaBoost classifier and model on the fit on X train, Y train. And model dot predict on X train, predict on X test. And whatever the train accuracy, test accuracy, and CV. I'm going to get train accuracy, test accuracy, and along with the CV score. And I'm going to observe this one. If once I observe this one, train accuracy, test accuracy is okay, but the CV score, whatever the CV score is there, the CV score is not equal to the test accuracy. Now it is not a good model. Now what I have to do? Hyperparameter tuning. Now what are the hyperparameters available within the AdaBoost classifier? Means by default, it is going to take the estimator is equal to decision tree. Means it is going to form the multiple decision trees. N estimators is equal to 50. Means by default, it is going to create 50 decision trees. So now what I'm going to do here, I'm going to take the N estimators between list of range of 1 to 51. And I'm identifying which is the best one. Means it is going to create with the AdaBoost with 1 estimator, AdaBoost with 2 estimators, AdaBoost with 3 estimators, AdaBoost with 4 estimators. Like this, it is going to create the multiple. Okay. And it will take time, just 2 minutes of time. Oh. Yes. Learning rate means how much it is going to take from the each decision tree, how much it is going to learn from the each decision tree. The maximum is 100%. You can try from between 0 to 100 between, 0 to 1. Okay. Now, once the best parameters are completed, I'm identifying the future importances. Same to same. In the yesterday's class, how we have done the same to same future importances. From the future importances, I'm going to create with respect to a data frame, and I'm going to identify which are the important futures. Let us see. Now, n estimators is equal to 20 is the best one, it seems. For the n estimators, that is AdaBoost with n estimators of 20. For that, I'm identifying the which are the futures importance. Now, total how many futures are there? 95 input futures. Out of 95, many of them are 0. Can you see? Many of them unimportant futures are there. So if I observe, if I convert this array, whatever the array is there, this array I'm converting as a data frame. After converting as a data frame, I'm identifying whichever the future importance is value is greater than 0. If I take this one, I can get only with respect to these are the column. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Only 15 columns are important. Out of 95, 15 are important. Remaining 80 are not important. Now these 15 columns only you have to consider in your X variable. You have to remove remaining variables. Now how to drop the remaining variables? We can't take the df dot drop and we can't write all the 50 columns one by one like this. Now, then what is the other alternate means? So here, this data frame, whatever the data frame is there, this data frame index values, what are the index values are there? These are the index, right? Index names. These index names, I'm converting to list. I'm converting, first I'm going to take the index. Index means I'm going to get the values. That values I'm going to convert to list. Now I have got the list of column names. These are the list of column names. Now in my X variable, this is my X variable, which is my X variable is of total 95 columns. In this X variable, I'm going to give the input as the list of important futures. Is that clear? Is this point is clear, guys? So we already know in a DF how to extract a single column, you know. If you want to extract a multiple columns, what we have to give? List. This list I'm going to take here. Whatever the this one is there, this entire thing I'm copying here. This list I'm copying here. Total my X variable, what are the X is there? Data frame name is X. Now within the X variable, that is 95 columns, it is going to identify these 15 futures and it is going to separate. And that one I'm going to consider as a new X variable. I'm going to take that one as a new X variable. Okay, that is the new X variable. So now this is the X. Now I'm having only 15 columns. Out of 95, I have removed 80 columns in a single shot. I'm considering only the 50 columns. Now 15 columns are ready. At the same time, n estimators of 20 is also ready. Now I'm going to create one more time the ADA boost. Now this time you can see the ADA boost train accuracy, test accuracy, at the same time cross validation also increased. Is that clear, guys? Now that's it. That is the ADA boost coding. Now what is the special we have done is, so yesterday's class and today's class, everything is same in terms of coding. Okay, first we have done the default model and default evaluation. Up to that it is common. Hyperparameter tuning, grid search CV. In the hyperparameter tuning, n estimators is the parameter, that is also common. After that, using the best hyperparameter, we identified the important futures. Up to that is also common. Third step also common. After identifying the important futures, now I have to drop. If you remember the yesterday's class, in the yesterday's class, I'm opening the yesterday's class. So in the yesterday's class, what are the future importances are there? Whichever the unimportant future is there. Yesterday we have identified only two unimportant futures, like in the decision tree. Let us open the decision tree coding part. Okay, yes. So here in the decision tree, if you observe this one, the coding part, yesterday we have identified these are the two unimportant variables, this one and this one. Only these two are unimportant. Since only two are unimportant, I have dropped directly by writing these two names. But in today's one, total 95 columns, out of which 80 of them are having 0, 0, 0. 80 of them are having 0. Now I can't write all the 80 names like this, right? Then what I have done is, for that reason, since considering of 80 of them separately, what I have taken is which are up more than 0. I have taken those one and I have got these 15 records, and these 15 records values I have selected and I have created a list for that. And using that one, I have selected out of 95 columns, I have extracted 15 columns. That is the difference which was done when compared to yesterday's and today's. Is that clear, guys? Got the point? That's it. That is with respect to ADA boost coding part. Any questions in the ADA boost coding? In data pre-processing, nothing changes. Data pre-processing irrespective of algorithm, common. If it is categorical data miss, you have to do the encoding. If it is normal data, if any missing values are there miss, you have to fill the missing values. That is common, irrespective of whatever you have. Is that clear? Done? Any questions? If you have any questions, you can ask. Otherwise, that is the end of the session for today. And I'm going to upload everything. STS notes was not uploaded. I'm going to upload the STS notes, and I'm going to even upload the today's notes also. Okay. In 50 minutes by 7:30, you can see. Okay. In this next 50 minutes, I'm going to upload that one. By 7:30, you can check your drive. Okay. Before starting the next class, I will upload the notes. Is that clear, guys? And in order to extract the data, in order to work on the new data sets, we are having two websites. The first website is called as Kaggle. Okay, from the Kaggle, you can type here whichever the data you want to work. For example, I want to work on the banking industry. Click on the banking. And here, wherever the heading name is data set is available, just click on that. And here you can extract the data. You can see here data. And you can just drag down slowly. And here there is a train.csv, test.csv. The train.csv, click on the download, and test.csv and click on the download. In that way, you can download the data. And you can work on the multiple data sets, right? This is one way. Okay. And you can get the more number of data sets. And the second way, second website is UCI repository. UCI repository. UCI machine learning repository. This is the one more website. Okay. So just in this website also, here you can type the whatever the name you want, and automatically you can get with respect to multiple data sets. Almost more than 50,000 plus data sets are available. For example, one of the data set is wine quality. So this is the wine quality where I'm having with respect to multivariate. What is meant by multivariate means it is a multi-class classification problem where in the output variable you are having 3 classes. Okay. And here you are having the data. So from where you can download the data here. So here data folder is there, right? Download the data folder. Click on this and you can download with respect to the CSV files. One by one CSV files. And data set description. Data set description means you can see the each column name. There will be multiple column names now. For each column name, what is the column name meaning is. For every column name, what is the meaning of the column name? That is called as data set description. Is that clear? So like this, you can download the data from the Kaggle or you can download from the UCI. Now, as of now, you are having some data sets with you. Like what are the data sets are available with you? Miss 1, advertising data set. 2, insurance data set. These 2 data sets which you have worked for your regression problem. One more, you are having with respect to diabetic data set. One more, you are having with respect to cancer data set, penguin data set. Today, I'm going to upload mushroom data set. These data sets are available for classification. If you remember, some data sets we have used for the data wrangling, like Titanic data set I have used it for in the data wrangling. At the same time, heart stroke prediction data set. Do you remember? Which I used for the discretization example. One data set which consists of 31,000 records, where in that heart stroke is there, either 0 or 1. That is also basically a classification project. You can select that data set. And you can apply the ADA boost on that. You can apply the decision tree on that. You can practice. Titanic data set, that is also a classification project. You can use the Titanic data set. You can use that. Like this you are having. And by end of the course, you'll have at least 20 to 30 data sets with you. 20 to 30 data sets will be there. So these 30 data sets you can practice. You don't need to even download from the Kaggle or UCI also. If you want to practice on a new data set, means you're already having the heart stroke data set, which is available in the discretization folder. That is data wrangling folder. Select that one and apply. Is that clear, guys? And still, if you want more, means you can download from this one also, either Kaggle or UCI. Is that clear? So That is the end of the session. And I'm going to upload the notes just in 10 minutes. Okay, by 7:30, you can check your, you can open your folders. That is classification folder. In that, I'm going to upload the decision tree coding part, random forest coding part, and AdaBoost coding part along with the mushroom data set. Everything will be added. Just give me 10 minutes of time. Done.